Hello, my name is Teresa Stack. I'm an associate professor at Montana Tech, and this learning unit will cover cohort studies as part of the Masters of Science class, Principles of Epidemiology.
By the end of this lecture, you'll be able to describe what a cohort study is and how it differs from a case control study. Remember, both cohort and case control studies are observational studies versus an intervention study or a clinical trial. You'll be able to look at the differences between the historic content of using cohort studies and how it transcends over time, and we'll do some calculations as well. So there are some really famous cohort studies out there. You may have heard of them before. The top one is the results from Sir Richard Dahl's study influenced our personal habits to smoke, to quit, or not to smoke, as well as national policies, bans on smoking advertising, bans on smoking in certain public areas, pictures on cigarettes. Now if we choose to smoke, it is with full knowledge that is linked to an increased risk of lung cancer. But in the 1920s, this was not well known, and lung cancer was on the rise in many countries. At that time, this was popular attributed to, at that time, people thought that lung cancer was attributed to air pollution, damp climates, and exhausts from motor vehicles, as well as carcinogens from the use of tar when making roads. At that time, there was no definitive evidence that smoking habits were linked to malignant growths in the lungs. Along came a British doctor, Sir Richard Dahl, who started the first major medical cohort study to find out what was causing this huge surge in lung cancer in Britain. He recruited 35,000 British male doctors into a prospective, forward-looking cohort study. There were two things going for recruiting doctors as participants. It was relatively easy to trace them through the years, as doctors need to stay registered to practice. And being doctors, they are very likely to have access to medical care. Their reported information was likely to be medically accurate. Dahl said, "I personally thought it was tarring of the roads. We knew that there were carcinogens in tar. It wasn't long before it became clear that cigarette smoking was to blame. I gave up smoking myself 2/3 through the study." The next study, which is still ongoing today, it's just absolutely amazing, is the famous Framingham Heart Study. It's hard to believe that in 1948, doctors had no idea that heart disease was in any way linked to high blood cholesterol. The fact that blood cholesterol measures are a regular part of health screening today is thanks to the Framingham Heart Study in Massachusetts, an ambitious project in health research in 1948. Starting with just 5,200 participants, all volunteered, that study has revolutionized the treatment of heart disease by linking it with hypertension and high cholesterol levels. As it happened in 1971, a further study of 5,100 participants, the children of the original cohort and their sponsors were recruited to carry this study into a second generation. The study is no longer just focused on heart disease. Now it includes cancer, dementia, arthritis, osteoporosis, hearing and eye disorders. A staggering 100,000 scientific papers have been published from discoveries made through the study of this cohort, giving us some inkling of real-life impacts that this study has had in our lives. Showing strong support, 3,900 grandchildren of the original Framingham Heart Study are participated in the third generation study in 2002. Key goals of the third generation study are to identify new risk factors for heart, lung, and blood pressure diseases, identifying genetics that contribute to good health and to the development of heart, lung, and blood health, blood disease health, and to develop new imaging tests that can detect very early ages of coronary heart disease and otherwise healthy adults. the EPIC European prospective study into cancer and nutrition. This study started in 1992 and spanned 10 European countries and involved more than 500,000 participants. It discovered that people who have a healthy intake of fruit and vegetables have a lower risk of developing cancers of the digestive system, lungs, bladders, kidneys, and ovaries. It established a positive link between low dietary fiber and colorectal cancer. The study also showed that smokers with high fruit and vegetable intakes ran a 40% lower risk of getting lung cancer than their fellow smokers who did not share a similar high fiber diet. Of course, the study emphasized that smokers who quit had a lower risk for developing lung cancer. And one that's kind of close to my heart because of when it came out, it influenced what my mother had done when she went through menopause. But the Nurses' Health Study, it is said to be one of the most significant studies ever conducted on women's health. It started in 1976 with its primary aim to investigate the potential of long-term consequences of the use of oral contraceptions. It involved 122,000 American nurses. The Nurses Study was upset in 1989. A second nurses study was set up in 1989 to study oral contraceptions, diets, and lifestyle risk factors in a population of young nurses. And it's looked at over 100,000 people over this period between 1976 and 1979. And then the last one is the Women's Health Initiative. Between 1983 and 1989, 160,000 American women ages 50 to 79 were recruited into this study. It researched the most common causes of death, disability, and poor quality of life in postmenopausal women, such as cardiovascular disease and osteoporosis. Different parts of the study looked at the effects of hormone, dietary modifications, and the effect of vitamin D. The study had to be stopped short when it was shocked to find that hormone replacement therapy increased the risk of women suffering a major heart attack. So your cohort study can be done either retrospectively or prospectively. And it's a group of people who are either followed over time, or we go back and we try to look at their exposure and then compare the incident rates of who develops these areas versus who doesn't. And there is a link here if you'd like to take a look at a video. Cohort studies are, of course, observational. Cohort studies is undertaken to support the existence of an association between an expected exposure and a disease. Subjects are grouped according to their exposure experience. This is in contrast to a case control study in which people are grouped based on their disease state. And then these groups are followed or looked back over time, and the outcomes are observed. So what is a cohort? A cohort is a group of people who share common statistical characteristics or experiences within a particular time period. It's also an ancient Roman military group of people who band together. Okay, so we have our source population, the same source population in which we might use a case control study, but then we break people out, or we put them in different categories, those who are exposed to the risk factor versus those who are not exposed to the risk factor. And there are different types of cohort studies. There's prospective, in which you look forward, so you study people over time, or this is also called a longitudinal or a concurrent study. So these three words mean the same thing. It's following a group of people over time, versus reassembling a group of people, reassembling your cohort, and then retrospectively looking at what their exposure patterns were. These are also called historic or non-concurrent studies. And remember again, it's the exposure, not the disease state, that's being compared. And again, this was a study that had taken place in Wales, and it looked at the number of cases of people who smoked versus the number of cases of people who didn't smoke. And what they were able to find out is that you were 32% more likely to develop lung cancer in an age group of over 25 when compared to a group of non-smokers. And this uses your cumulative incident rate, right, which looks at person years versus just your strict incident rate. I'm sorry, this looks at your incident density. Scratch that. It looks at your incident density, which is your person years, versus just the number of years in which people were studied. So some of the advantages is a cohort study. The exposure is known to precede the outcome or the disease of interest. It can be direct. You can directly calculate an incidence of exposure versus an incidence of non-exposure. Can evaluate multiple outcomes as well suited for common diseases or events. Can also be used for rare events. The disadvantages are it's inefficient for rare diseases or delayed outcomes because you have to study people over a long period of time. You need a large cohort for statistical significance, and changes in exposure change over time, or exposure changes over time. So you might have started off smoking at 18, but by the time you were 21 you stopped smoking, and then when you were 25 you started smoking again. So it's really hard to kind of tease out those variables. And then members, well, that's the example of members leaving and coming back into the study. People also die or they don't follow up anymore, and they can be really expensive. So what we calculate as opposed to an odds ratio is an incident rate of exposed versus unexposed and an estimation of the relative risk or the attributed risk. So in our cohort analysis, instead of having diseased versus non-diseased, that's what we would have had in our case control, we have exposed versus unexposed. And then we have diseased versus not diseased and diseased versus not diseased, right? So the setup looks really the same if you looked at the case control study first. And if you haven't, then it'll look the same anyways. And so our incident rate is the number of exposed with the disease divided by the number of exposed people. So we had 40 out of 50 people, or 0.8, were exposed and had the disease, and that would be 80%. So 40% had the disease over the population that was exposed. 40 over 50 is 80%. The incidence among the not exposed is we had our exposure group was 50, and 15 out of 50 people developed the disease, or 30% developed the disease. So when looking at this slide, don't make the mistake here and think that that is a division sign. It isn't. It's the outcome or the disease. Because in looking at occupational data, sometimes you're looking at an injury, and we don't call an injury a disease. So how many people develop a musculoskeletal disorder, that would be an outcome versus a disease. But you can still use a cohort study for that. So it's really the same kind of math. Our total group, our outcome, our total group, and our outcome. So the other thing that we can do when we take a look at our, well, this is just another way to look at our exposure variables. So then after we calculate our incidence rate of our exposed versus our incidence rate of our unexposed, then we can calculate a relative risk. And the relative risk is simply the incident rate of our exposed, which would be our 0.8 here, over our incident rate of our unexposed, which is 0.1, and that equals 8. So exposed people are 8 times more likely to develop the disease than unexposed people. And I see that I have a math error here because 15 divided by 50 equals 0.3, and therefore this should have been 0.3, and this should have been 0.3. And this answer becomes 2.6. Sorry about that. So just a comparison of your cohort study versus your case control study. So relative risk in your cohort study is very similar to using your odds ratios in your case control study. So it's your incidence of your exposure over your incidence of those not exposed, and your relative risk is simply the ratio or the division of the two. And your odds ratio is calculated as the number exposed divided by the number of unexposed over the number of exposed divided by the number of unexposed cases and controls. So let's find the relative risk for this particular set of problems. So first we need to find the incidence. The incidence of lung cancer among smokers is 70 divided by 7,000. The incidence of lung cancer among non-smokers is 3 divided by 3,000. The relative risk is our 10 over 1. It's the division of these two numbers. And we could make the statement that lung cancer is 10 times more common among smokers than it is among non-smokers. So what's our attributable risk? Our attributable risk is something that's really hard to say. So in our cohort of smokers and non-smokers, we had exposed and unexposed. But there are some background level of people who develop lung cancer even though they don't smoke. And so what we want to see is how much more does smoking increase your risk of developing lung cancer over the regular background rate of you developing lung cancer even if you don't smoke. And this is called attributable risk. And it's pretty easy to calculate. You just have to do a subtraction of the incident rate of your exposed over your incident rate of your non-exposed, and then we divide this by our exposed. So another way of looking at it, this is a graphical representation of looking at it, and I think that you're able to see that, it looks like your relative risk looks much bigger than your attributable risk, because you have to basically subtract this out of your data set. So what is our attributable risk? So we know that our relative risk was 70 over 7,000 divided by 3 over 3,000. And this was our relative risk. What is our attributable risk? So we take our Relative risk, incidence among exposed. We subtract out the incident rate of the unexposed. We divide it by our exposed group, and we look at 90%. 90% of the cases of lung cancer among smokers are attributed to their habit of smoking. Have a wonderful day.